Good morning, students. Today we are going to discuss the question based on electrochemistry. This question is raised by my student. And this question is based on electrochemical cell. Have some clarification about there is some concept. I think you know about the concept. In 12th standard, it is there. So in electrochemistry, there are two parts, electrochemical cell and electrolytic cell. And this question is based on electrochemical cell. Let's see what are the given data. Here the given data are standard EMF for the half cell. Why I'm saying this is a half cell? Because the reduction only happened. That is Cu2 plus is getting 2 electron and it is converted into Cu. This is called the reduction reaction. Why we are calling this as a reduction? Because reduction, the meaning for the reduction will be addition or gain of electron. So usually the complete shell will have reduction as well as oxidation, but the half cell may have reduction or oxidation. They have given the standard condition potential, standard EMF for that. EMF or potential, anything will be the same. So standard reduction potential of Cu2 plus and Cu they have given, and then the solubility product KSP is nothing but the solubility product. That is what they are trying to say. They are not taking the strong electrolyte. For example, CuSO4 is a strong electrolyte. When whatever the percentage of CuSO4, that is, if you are adding 0.1 molar CuSO4, you will get the 0.1 molar Cu2 plus in the solution. Because look at this, if I am taking CuSO4 strong electrolyte, Cu2 plus will give, that is the, if you are taking 1 molar CuSO4, you will get 1 molar Cu2 plus because it's a strong electrolyte. But here CuOH twice is not at all a strong electrolyte. If this is a strong electrolyte, we will not get the same Cu2 plus ions as we have taken. So we don't have a Cu2 plus, the same Cu2 plus we don't have. Think like that. If you are taking 1 molar, we won't get the same 1 molar here because it's a weak electrolyte. It's a weak electrolyte. That's why they have given the data, one more data, that is to find out the Cu2 plus concentration. They have given the one more data, that is KSP. Okay, so KSP they have given, and then pH they have given. Let us check how the pH affects the Cu2 plus concentration. Let us check that one. Okay, first what these are the given data. KSP they have given. We don't know why they have given KSP. We don't know why they have given that half cell EMF. But what they are asking, let us check. And then one more thing, pH also they have given. So pH, from the pH we can calculate something. I will tell you that. So what they are asking, the reduction potential for the Cu2 plus Cu couple is has been asked here. You may think, ma'am, here they have given the reduction potential, but why they are asking the same? You may think, but the given reduction potential is at standard condition. That is for 1 molar, 298 Kelvin, and then 1 atmospheric pressure they have given. But the thing they have asked here, the reduction potential at pH is equal to 14 for Cu2 plus Cu. They are asking the EMF of the half cell at any condition, not a standard condition. At the given condition, they are asking. They may maintain some other concentration. So they are asking this one. So look at this. This formula is having EMF. They are asking this one. Which one? This part they are asking. And the given part will be the standard one. This one. This one is a given part. And then 0.05912. This is actually for unit, and the number of moles of electron that has been transferred, and the log Q. Q is a reaction quotient. It's like equilibrium constant, but not at equilibrium condition. So Q is equal to product concentration divided by reactant concentration. Look at this. In this case, the product concentrations are there. The product concentration and to the power of mole coefficient of the corresponding product, and divided by the reactant concentration to the power of the reactant mole coefficient. Okay, let us check what they are asking. So they have asked this one. I'm going to give a complete formula for you. That is, they are asking the E half cell for the reduction Cu2 plus Cu at the given condition. And then they have given the standard condition Cu2 plus Cu reduction potential. And then the formula is having 0.0592 Usually I will take that 0.0592 into 0.06, because some calculation I am just skipping that, because in NEET and the JEE we could not calculate by the calculator, right? So I have simplified that one, 0.06. But we can do that. We can do that. Mostly the answer will be very, very close to the exact answer. So don't worry. And the number of electron we should write. We have to calculate the number of electrons. We will calculate that one. And then log of product concentration to the power mole coefficient of the product, and then reactant concentration. So product concentration divided by reactant concentration. Maybe it may be X, it may be Y. I will check. So I have to write the half cell equation. Then only I can find out what is the product, what is the reactant. So here they are asking the reduction potential for this one, right? Reduction potential for this couple. So I'm going to write the product and the reactant. Cu2 plus is gaining 2 electron. This is about the product, and this will be the this is about the reactant, and this will be the product. So the product is in the solid form because it is converted into metal, and it will be in the aqueous form. So solid form could not be considered in the reaction quotient. So I'm going to apply, that is substitute all these things in the given formula. So E naught Cu2 plus Cu. What is the data they have given? Shall we directly apply the data? Here, look at this. The data will be 0.34. Okay, let us apply this one. 0.34 and 0.06, and the number of electrons will be 2, and the log of Cu, so solid you should not take, right? So product side not necessary to take that, just you have to take it as 1. And then in the denominator Cu2 plus, there is no mole coefficient in front of this one, there is only 1, right? So not necessary to write that. You should be very careful, okay? Because sometimes they will intellectual student even miss that by careless mistake. Okay, then we will do that. So here the 0.34 will be remaining as such, and then it will be 0.03, and the log of 1 by Cu2 plus concentration. Here the problem starts. How we can find out that Cu2 plus concentration? Here the thing happen. Here they didn't give any idea about the Cu2 plus concentration at all. They have given only pH and then CuOH twice. So where we can find the CuOH twice, Cu2 plus concentration? From the solubility product we can find that. So they have taken CuOH twice. We know that this is a weak base because transition metal hydroxides will be the weak base. So here Cu2 plus and 2OH minus there, but it will be in equilibrium condition. So here we need to find out the Cu2 plus concentration, but we don't know about that. We know that the solubility product will be 10 to the power minus 19. So when I'm applying the solubility product here, look at this. When I'm applying the solubility product here, if the solubility, that is S molar, is getting solubilized, look at this. 1 molar is getting solubilized means 1 molar Cu2 plus will be formed, and 2 molar OH minus will be formed. So if you are taking S molar COH, that is if the solubility, that is if S molar is getting solubilized, the same S molar will be formed here and 2S molar will be formed here. So KSP will be equal to, not necessary to take this one. Solubility product means you should give the that is you should just multiply the concentration of ions. That is called the solubility product. So S into 2S to the power squared, because that is KSP, that is the equilibrium constant, will be equal to Cu2 plus and then OH minus square. This is called solubility product. Solubility product will be, formula will be like this. For any sparingly soluble salt which is in the solid state will have an ions like this, and the solubility product is having the formula like this. So we are having the formula like this, but anyway here what they are asking, what we need, yes we need. So you may think, ma'am, we can just do this one here, yes, and here 4s squared, so 4s cube will be there. From then we can easily find out that yes, like that you may think, but they are giving one more twist here. They are doing this one, they are not at all actually doing this one in neutral condition. They are doing with some other pH. So the pH will definitely affect this equilibrium. Why? Because that pH is having 14. So 14 pH means, what is the pH is 14 means the hydrogen ion concentration will be very, very less. And what will be the POH? POH will be 0. When the POH is 0 means OH minus concentration will be 1. Look at this, OH minus ion concentration is very, very high here. When you are comparing 10 to the power minus 19, the OH minus ion concentration is very, very high. That's why you should take this concentration as 1. So at 1 molar concentration of OH minus, due to the common ion effect, definitely this equilibrium getting affected. So definitely the solubility also getting affected. So we have to find out the new solubility when we are having the pH 14, that is OH minus ion concentration 1. Let us find out that. I think you have learned that in your 11th standard. If you don't know, if you are having any doubt on that equilibrium, you please raise your doubt to my WhatsApp number 7010802531. Okay, I will help you for that to get the clear clarity about the equilibrium concept. Okay, no issues. And look at this here. I am going to take that same CuOH twice equilibrium part at 1 molar concentration of OH. So now we know the concentration. Usually 2s will be there and 1 molar concentration will also be there. But 2s will be very, 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 very less compared to 1 because it's about 10 to the power minus 19, right? Look at this. 10 to the power minus 19 solubility product means it will be very, very less. So not necessary to consider that as 2s plus 1. So you can take that as 1 itself. And the new solubility we don't know. We know that the solubility, that is yes, new solubility we don't know. Ksp will be equal to, what is that? S into 1 now, right? So now we can find out the solubility. That is solubility means that is Cu2 plus concentration. K is base 10 to the power minus 19. So you can substitute this one. So Cu2 plus concentration, finally I found. I'm going to substitute that in our equation. Shall we do that? Yeah, look at this, 0.34 and minus 0.03 log of 1 divided by 10 to the power minus 19. So 0.034, 0.03 into 10 to the power 19, log of 10 to the power 19 it will be there. So log 10 to the power 10 to the power 19 will be nothing but simply 19, because log 10 the power will be coming in front as multiplication and then it will be simply 19. So when you are doing this one you will get the answer 0.34 minus 0.57, so minus 2.3. So I'm just taking this one. Yeah, these I will just mark this one. Yeah, minus 0.23. This will be there in your answer. Here the main important thing is directly you should not that you should not take the Cu2 plus concentration from the Ksp. So Ksp you have to find, but in the pH 14. That's the main point. Cu2 plus concentration cannot be directly substituted here because Cu2 plus CuOH twice is a weak electrolyte. That's the important point that you should realize because sometimes we will do some careless mistakes on this one. So for strong electrolyte, you can apply directly the Ce2 plus concentration. For weak electrolyte, we have to apply the concentration by giving the solubility. Thank you, students.